We'll be talking about the gas laws experiment, experiment number 7. We're going to be thinking about 3 different parts in this experiment: the relationship between pressure and volume, which is Boyle's law, the relationship between temperature and volume, which is Charles' law, and the relationship between moles of gas and volume of gas, which is Avogadro's law. In this experiment, instead of collecting the data in lab, what you will do is take the data that you're given to prepare graphs and determine whether the relationships between all of these variables and volume are direct or inverse. So we'll start with a description of Boyle's law. For Boyle's law, you'll be given several different volumes of the syringe barrel. Here I'll just show you 2 of them as an example. So let's say the volume on the syringe barrel was 14 milliliters and then 12 milliliters. The actual volume, we have to account for the fact that there is an amount of air that's trapped between the syringe and the pressure gauge. So we're going to add 4 milliliters to get the actual volume. So for this one it's 18, for this one it's 16. You'll also take this into account if you do any calculations with the graph that you obtain. At 14 milliliters, the volume, the pressure is 50 millimeters of mercury. And when the volume is 12 milliliters, the pressure is 155 millimeters of mercury. The pressure on the gauge doesn't take into account the pressure of the room, so the atmospheric pressure that's also acting on the gas. So for this experiment, we're going to use a value of 756 millimeters of mercury. So it's recorded from a barometer, which measures atmospheric pressure in lab. So here 756 plus 50 is 806 millimeters of mercury, and 155 plus 756 is 911 millimeters of mercury. Then we take the inverse of that value, so essentially 1 over 806, and we get a decimal. Here we have 1 over 911. This value is 0.00110. It's useful to perform these calculations in Excel so you don't have to transfer any of your data from the calculator to Excel. Once you have all of the values filled in this table, in Excel, what you're going to do is make 2 graphs. So it's helpful to use the Excel guide provided to you to go through the steps to make these plots. The first plot you're going to make is volume versus total pressure. So actual volume versus total pressure, that's graph 1. Then you're going to make another graph where you take actual volume and the inverse of pressure, and that's graph 2. So you're going to make 2 plots, and you're going to determine which one is more linear. So the linear plot is the one that has an r squared value closer to 1. It's helpful to adjust your axes so that you can see whether the data is truly linear. If you have any questions, be sure to ask your instructor. In part B, we're investigating the relationship between temperature and volume. And again, you have data provided to you, but the data that you're given is in degrees Celsius, so we also need to convert it to the temperature in Kelvin in order to understand and be able to prepare the plots that we need to understand the relationships. So in both of these plots, you're going to be plotting temperature on the y-axis and volume on the x-axis. But notice the units of temperature on this plot, graph number 3, are Celsius. This one is in Kelvin. One of these will have an intercept close to 0, and 1 will have an intercept close to 273.15. And then you're going to determine which is the correct relationship that gives us a linear relationship between temperature and volume. The next part of the experiment is investigating the relationship between moles of gas and volume of gas. So the reaction that we're investigating is a double displacement gas evolution reaction. So the products of the reaction are NaCl plus water plus CO2. And this is a gas, and you know that gas is forming in this reaction by the formation of bubbles. And notice the mole ratio in this equation is 1:1 between sodium bicarbonate and CO2. So there are different masses of sodium bicarbonate that we add in a range from 0.03 to 0.15 grams, and you'll see those values on the spreadsheet. So to go from grams of sodium bicarbonate to moles, we just divide by the molar mass of sodium bicarbonate. And notice, because we have a 1:1 relationship between the moles of sodium bicarbonate and moles of CO2, these columns will have the same values. So you can just simply copy them over. These numbers, the initial and final volumes of the syringe, are given to you on the Excel file. And to find the volume of gas, you just take the final volume minus the initial volume. Then you plot volume versus moles. So here, notice that the axes are reversed from what they were before in the other graphs that you're making. And you should see a linear relationship here between the volume and the moles of gas. One thing to keep in mind, though, is if we ask you about grams of NaHCO3, or how much sodium bicarbonate went into the syringe, you would use the trend line. But the thing that the trend line tells you from the graph is about the moles of CO2. So if you know volume, and what you can do is go from volume of CO2 to moles of CO2 using the trend line. So we use the trend line for this. And then to go from, sorry, that's very messy handwriting there. This is where we use the trend line. And then if you want to go from moles CO2 to moles of sodium bicarbonate, you would use the mole ratio, which is 1:1, so those are equal. And then if you want to get to grams of sodium bicarbonate, this is where you would multiply by the molar mass. So you will see 5 graphs when you're finished with this experiment. You'll turn that in on your data sheet, and make sure you answer all the questions provided throughout the experiment, as well as the post-lab analysis questions on your Excel file.